Welcome to part 2 of our video showing you how to use EDF's U.S. natural gas leakage model. Let's try an example. First, we want to determine the impact of a switch to natural gas in both the power and transport sectors. Let's say about 1/3 of coal electricity generation switches to natural gas. Let's also say that in the transportation sector, natural gas shifts to 50% in both the light-duty and heavy-duty vehicle fleets. Let's further assume that any new natural gas plants run more efficiently than the current average. You can see that the graph and the table have both updated with the results. The results show the climate influence from comparing your policy case scenario to the baseline, or the change in cumulative net radiative forcing relative to total 2010 U.S. greenhouse gas emissions across a variety of time horizons from year 0 to year 100. Methane, the main ingredient in natural gas, is a greenhouse gas pollutant many times more potent than CO2, but it decays more rapidly, which is why it's crucial to differentiate between short and long-term climate impacts. Here's a larger version of the chart. Negative changes indicate climate benefit, while positive changes indicate climate damage. If you look at the total climate influence curve in red, you'll see that this scenario results in some slight climate damage in the very short term, up until about year 10. After that, it results in slight climate benefits. The benefits are bigger in the longer term because the shift towards natural gas increases the amount of methane released, and methane is more potent in the short term. Notice that the benefits in the power sector are offsetting the damages that occur in the transport sector. The model assumes that changes occur immediately, providing a snapshot of the climate impacts resulting from the user inputs. Let's also take a look at the crossover leak rate tab. Here, the model calculates the leak rate below which the technology switch in a specific sector is beneficial to the climate for a given time frame. You'll see that the all time frames crossover leak rates for the transportation sector, specifically the heavy-duty fleet sector, is around 1%. Which means that we'll have to reduce the leak rate to less than that amount in order to achieve benefits in that sector across all time frames. It's not necessary to refer to the crossover leak rates tab, but it's there in case you're interested in additional information. Let's try it. We'll change the policy case leak rates to a total of 1% across the supply chain. Now you'll see that benefits have increased significantly, and this time the impact attributable to the transport sector is a climate benefit. We hope these videos have been useful to give you a taste of what our tool can do. Thank you for watching, and we hope you enjoy using the model on your own.